Find the intersection of two planes. So two planes that are not parallel will intersect in a line. As an example, it's always a good idea, I think, to use the room that you're in. The floor is a plane. Take one of the walls, that's a plane, and look at the intersection. That should be a line. Now that is assuming that the planes are not themselves parallel, like the floor and the ceiling might be. So the normal vector for the first plane is 3, -1, -4, and the normal vector for the second plane is 1, -4, 1. These vectors are not parallel since one of them is not a multiple of the other, and therefore these planes are not parallel, and therefore they intersect. So the planes will intersect in a line, and so if we can find 2 points on the line, then we'll have a direction vector for the line and a point, and so we can write the equation of the line in vector form. We can take the point in vector form plus t times the vector pq. That'll be the vector form of the equation of the line. So let's find p and q. To find p, we will let z equal 0, and that will give us in the first equation 3x minus y equals 3, and in the second equation x minus 4y equals 2. And now we'll solve this 2 by 2 linear system. So this is just two lines in the xy plane. We want to find where they intersect. So we'll substitute here. X is equal to 4y plus 2, and we'll substitute that into the first equation. 3 times 4y plus 2 minus y is equal to 3, so 12y plus 6 minus y is equal to 3. 11y is equal to -3. Y is equal to -3/11. And then if we come back over here and plug that in, x equals -12/11 plus 22/11, so x equals 10/11. And therefore we have 1 point in our intersection. It is 10/11, -3/11, 0. That's a point in the intersection of the two planes. This point should satisfy both equations if we did our algebra and arithmetic correctly. Okay, let's find the point Q. We'll just pick another value for z. Let z equal 1. Then the first equation becomes 3x minus y minus 4 equals 3. So equals 7 if we put the 4 over there with the 3. And x minus 4y equals 2 minus 1, which is 1. So another linear system. Let's solve this one for x again. X equals 4y plus 1. Plug that in over here. 3 times 4y plus 1 minus y is equal to 7. 12y plus 3 minus y is equal to 7. 11y is equal to 4. Y is equal to 4/11. And then x is 16/11 plus 11/11, which is 27/11. X is 27/11, and so therefore the point Q is the point 27/11, 4/11, comma 1. So now for the actual the equation of the line of intersection in vector form, we can write xyz, a point on the line, xyz is equal to, we'll use the position vector of either one of these. Let's go with P. 10/11, -3/11, that's not a 3, -3/11, comma 0, bracket, vector form. This is the position vector for the point P. We have to write this first thing here in vector form because we want to add it to a vector. And so we have plus t, that's our parameter, times the vector pq. So we'll take the components of Q one at a time and subtract the components of P. So 27 minus 10 is 17 elevenths, 7 elevenths, 1. So there's the line of intersection of the two planes.